Okay, now that we've gone through the syllabus, we've gone through the video orientation, how to navigate the Blackboard system and see how the course is organized, and we've also introduced ourselves. Let us talk about what chemistry is, okay? So what is chemistry? By definition, it's the science that seeks to understand what matter does by studying what atoms and molecules do. So in a gist, we study atoms and molecules. And chemicals make up everything around us. See, we have this perception that anything chemical is bad for us, but chemicals are really found everywhere because chemistry is the lead in your pencil, which is really not lead at all. That's why I put it in quotes. Actually, your pencil doesn't have lead, but a mix of graphite, a material composed of pure carbon. The interesting thing is that lead is used in those vests that you put on when you go to the dentist because they want to just take an x-ray of your teeth. They don't want to expose your body to harmful x-rays that is unnecessary. But the graphite in our pencils is just pure carbon. What's more interesting is that diamonds are also made up of pure carbon, but they have completely different properties because the lattice structure of the carbon atoms are arranged differently. And this is what I mean. In diamond, which is the hardest material on Earth, you see how the lattice structure of these carbon atoms is intertwined very skillfully by nature. In graphite here you see, yeah, we do have carbon, but the way it's organized is in sheets. So if I may ask you, if you just look at this, which is easier to break, this structure or this structure? And of course this is going to be the structure that's going to easily break, right? That's why you can break lead in your pencil or graphite in your pencil. Now, this, on the other hand, is a lot more expensive. So isn't it amazing how these two things are both made up of pure carbon, but completely different? You would never think to associate the two. Also, chemistry is the fizz in your soda. What your soda is just carbon dioxide, sugar, and water mixed together. We force the carbon dioxide gas in there by pressure and close the can. When you open the can, you let out all that carbon dioxide. And so that is how your soda becomes flat when it gets rid of all its carbon dioxide. Another interesting thing about phosphoric acid found in soda is that it gives it flavor and stops the mold and bacterial growth to prolong its shelf life. But guess what? It's been linked to bone loss as excessive phosphoric acid binds to the calcium in the gut and prevents uptake in the bones. And you know, calcium is good for our bones. So if we're reacting, if phosphoric acid is reacting with that calcium, it's binding it, it's not letting it get into our bones, and so we get bone deficiency. Catherine Tucker did a study on this at Tufts University, and she found that actually women more than men, because women are more risk for osteoporosis, had an impact if they drank more than 3 12-ounce servings of cola per day. So they lost 2.3 to 5.1% lower bone mineral density in the hip compared with women who consumed less than 1 serving per day. So chemistry ties into health. And most of all, chemistry is you. It's who you are. You see, the stars cook up elements that are found in the universe in our bodies. When the Big Bang took place about 13 billion years ago, we only really had hydrogen in the stars, which is the first element you'll find on the periodic table. And then through evolution and through the process of creating the universe, more and more elements were made. And us here on Earth, after 13 billion years, have 60 atomic elements in our bodies. Some are more abundant, like oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus, whereas others are, we just need a trace amount of that, or there's a trace amount, but nonetheless they are essential to life. So you see, this is a picture of the DNA backbone, and all it is is just hydrogen, oxygen, nitrogen, and phosphorus combined. So when it comes down to it, we're really just a big chemical reaction, a big complex chemical reaction. And so this is what chemistry is all about, and much, much more. And we're going to learn about this throughout the semester.